No. So here's paper in your hands and some notes to help us work our way through 3.4. 3.4 is the last new learning we'll have for a couple days. So it's Friday right now. We're going to try to go through this paper. There will be a homework built off of this tonight that'll be due for Monday. Monday I'll give you a sheet that would be due Tuesday that reviews everything we've done in this equation chapter so far, 4 lessons worth, and then we'd be looking to take a quiz on Wednesday. And you won't have anything new to pick up until we get to Thursday next week. So the homework we're going to do, the good news, there's good news and bad news. What do you like first?
Bad news.
The bad news is it's a bunch of word problems. So I think algebra history, there's probably a minority of students in algebra history who really are happy when they see story problems. More people get a little grouchy about it. The good news is the homework, we're only looking to do a handful of problems. But here's how I'm going to want you to do these tonight. The homework tonight is going to start on 111. 111's numbers, we're going to work from 1 to 5 are going to be 5 problems that are very much like the 5 we're about to practice. And I'm going to want you to do them the same way we're doing the 5 that we're about to practice, with like some layers of stuff that we're working out. Then there's a number 6 that I'm not going to make you do all these steps on. Number 6, you can just do it. And then there's also on page 112, there's a number 2 that has like an ABCD. You don't have to do all these steps on it. You just kind of do the problem. Let me start with that first. The 6 and the 2, ABCD. It's just going to tell you stories like the sum of a number and 3 is 10. And then you solve it. So if I say the sum of a number and 3 is 10, what would you write? The sum of a number and 3 is 10. X plus 3 equals 10. And then you'd solve that and you'd get 7. The homework's going to get easier as you go, because on page 112, this number 2, or problems like that. The number 6 on the homework is a problem like that. You just write an equation like we've done many other days before, and you just solve it. But they're going to use all your magic words like sum, product, quotient, difference, all that kind of stuff. What makes 1 to 5 worse is they're just giving you a story in a paragraph. They're not using any of the magic words. So what I'm going to have you do is go through this series of steps on each problem. You may like it, you may not like it, but it is what it is. So the first thing I'm going to have you do for each story is just write what's called a word equation. So number 1 on your notes paper says you go shopping, you buy some DVDs, you eat lunch. The DVDs are $15 a piece. Lunch costs just $7. Altogether, you spent $52, and we're going to try to set out on how many DVDs we bought. So here's the first thing I'd want you to do is find in that sentence like 3 different things that we're keeping track of. So what's like one thing we're keeping track of in this experience?
52?
No numbers, just words. DVD stuff. We're spending some money on DVDs. We need to keep track of that. We're spending some lunch money. We need to keep track of that.
How much we spent altogether?
And then there's a grand total of money. We're keeping track of that. So when we write the word equation, I'm looking for you to talk about DVD money, lunch money, and total money in some way. How do those 3 things go together? Adding, subtracting, multiplying, dividing? How does the DVD money, the lunch money, and the total money like fit? Adding. Add which 2 to equal the third?
The X7 and the DVD amount to make 52.
Don't even try to use the 52 yet. Just lunch money, DVD money, total money, which 2 add to make the third one?
Lunch money and DVD money.
Equal the total money. So there's our word equation. Number 1, word equation, something like DVD money plus lunch money equal total money. Just words, no numbers. Come back to that one. Let's go to 2. So 2, we read the story. There's 8 lunch tables. There's 104 people that are going to get seated at these tables. We're trying to figure out how many people are at every table. Forget about the 8, forget about the 104, don't try to use any of the numbers yet. But just using words, there's like 3 amounts of stuff that all interact with each other in this story to make some math happen. What's one thing that we'd have to have, like, known?
Lunch tables?
How many tables are there? Yeah, let's say count of tables would be a thing. Yes.
How many people?
Well, we'd have to say another word or two for that.
A total of 104?
Okay, total people would be a thing we'd be keeping track of. What's another thing that would be part of this interaction other than how many tables, other than how many total people? What would you have to do lunchroom math other
People per
than?
table?
What's that?
People per table?
Yeah, like seats per table. How do those interact? That's our 3 things. Would we add, subtract, multiply, divide? What's up with this?
Divide?
Maybe.
Is it subtract?
Definitely not.
Multiply?
Possibly, yeah. I would think more in terms of probably multiply. What would you? But if multiply is an option, so is divide, because anything you can do forward, you can do backward, like opposites, all that stuff. But I'm going to go a multiply route on this. Which 2 things would you multiply to make the third one?
Lunch tables and seats?
Yeah, the table count times the seats at each one would equal the total seats. Something like that would be a good word equation. So count of tables times seats at each equals total seats. There's a pretty good word equation. Let's come back to that one. So 3, we got a job. We're making $34 for working 4 hours. We're getting a $6 tip. We're trying to figure out our hourly wage. Ignore the 34, the 4, the 6, the numbers don't matter, but there's like 3 things here that are represented in some way by math. What's one thing that is a math item?
Wait, like how much money you make?
For what portion though?
Hourly?
Okay, so there's some hourly money. I would take that.
Is tip money?
There's tip money. I would take that.
Working?
And then everything's some kind of money. You got your hourly money, you got your tip money.
Your own money?
Paycheck?
Yeah, what does your paycheck represent, I guess?
The total?
The total, yeah, there's like a total amount of money. So you've got some hourly pay, you've got some tip, you've got a total pay. What math links them together? Adding, subtracting, multiplying, dividing 2 of them to make the third. What's up?
Add?
Adding. Adding which 2 makes the third?
Tips and
Tips.
hourly?
Tips, yeah, your hourly money plus your tip money would equal your total money. Something like that. That would be a good word equation. Let's come back to that one. To the back for 4, I'm going to say write a word equation, not possible. Okay, I didn't tell you the same kind of story in 4, so that's more like the easy one I said you'd have, that you don't have to do all the steps. We'll come back to 4 in a little bit. 5 makes you happy, there's cookies. So there's 45 cookies that got eaten by 10 people. There's 5 leftover cookies that people probably are trying to pocket and take them home. We're trying to figure out how many cookies each person ate. But before we even deal with the 45, the 10, the 5, the math, just there's 3 different types of things that are being counted here. What's a thing in this story?
How many cookies people eat?
There's cookies that got eaten.
Cookies that aren't eaten?
There's cookies left over.
And how many people there were?
Cookies they were?
Yeah, there's total amount of cookies. How are those going to interact with each other?
Divide?
Nope.
Subtract?
Maybe.
Add.
Probably. Add which 2 to make the third?
The Cookies and leftover?
Yeah, the cookies eaten plus the leftover cookies would equal the total cookies. It takes practice to be able to do that, but that's not a bad thing. It's a good thing to be able to like see a story, kind of figure out without even worried about the numbers, like how the different amounts of things somehow fit together with math. That's a good like life math skill. Question about the word equation stuff? So let's go back to 1, and we'll just punch through and finish them one at a time. So 1, you want the variable always to represent the thing you don't know. So in number 1, what is it that you don't know?
How many DVDs?
How many DVDs? So the variable line, right, x equals count of DVDs. X equals count of DVDs. And then let's try to match up the numbers now into the right slot. So the total money is probably the easiest one. After the equals, what goes in the total money slot?
52.
52. The lunch money is probably the second easiest slot to fill. The lunch money was 7. So something plus 7 equals 52. The DVD money has to have something to do with the X, because we need an X in here somewhere.
15.
And it also has something to do with that 15. What would you do if you bought X DVDs and it's $15 per DVD? What math would you have to do to figure out your DVD cost?
Divide.
Like if I said you bought 2 DVDs, what's that costing you?
30.
30. If I said you bought 11 DVDs, what math would you have to do?
15 times 11.
I'm saying you bought X DVDs.
X times 15.
X times 15. So the equation would be 15x plus 7 equals 52. 15x plus 7 equals 52. Then let's solve it. Do some opposites would be your first opposite.
Subtract 7.
Subtract 7 from 52 gets you
45.
45. Then you'd
Divide.
divide.
15.
Divide 15 into 45 goes
3 times.
3 times. And then for these, when it's a story, your check is just, does this seem like a reasonable thing? Does that seem reasonable that you'd buy three DVDs and spend $7 for lunch, total's 52? Does that sound like a shopping trip a human would take?
Yep.
Yep. What if it said you bought 3.6 DVDs?
No.
No, they don't let you do that at the store. If you try to cut up their DVDs, you bought that 4th DVD. That's 3.6 DVDs. It's not an option. If it said you bought 300 DVDs, no, you bought -8 DVDs. No, those are like dumb answers because you have a real story to measure those up with. If you're in the middle of page 108 yesterday and your answer is -8, did that make sense? Probably, but -8 DVDs doesn't make sense. So 2, we said table count times the seats at each equals the total seats. Where's the 8 go?
Count of tables.
That's the table count. Where's the 104 go?
Seats for each.
That's,
Well, seats. I don't know.
what's the 104?
People.
That's the total people.
Uh,
So what's the X? What don't we know?
seats.
Where? Total?
No.
How many people are in each table?
Yeah, the seats at each table. The variable you're always going to find in the question. Wherever there's the question asked, that reveals what the variable is. The variable is what you don't know, and what you don't know is going to be part of the question. So pick a variable would be something like, right, x equals seats at every table. And if we fill in the slots that we had, we'd end up looking at 8 times x equals 104. 8 times x equals 104. Then solve it. To solve it, you'd
I did 1 and 4 divided by 8.
Yeah,
And I got 13.
13. Does that seem like a thing? You go in a lunchroom and there's 8 tables, 13 people at every one. There's 104 people total. Does that seem like a lunchroom that could happen in the human world? I'd say yeah. If you had 12 and a half people, if you had negative people, if you had 1,000 people, like at each table, like those are all crazy answers. So 3, let's pick our variable. What don't you know?
Hourly wage.
Your hourly wage. So variable X would equal hourly wage. The word story we had was hourly pay plus tip equals total pay. So total pay is easy to fill in. That was the
34.
34. The tip is definitely given to us,
$6.
6. But what we don't know is what you're making on your hourly pay. To figure out what you're getting paid for hourly pay, you need to know 2 things. What are you making for every hour, as well as
Tips.
no,
How long?
you're working. So how would we figure out that hourly part of this person's pay if the X is what they make for each hour? How long do they work?
4 hours.
4 hours. It's got to use both of those things. If you worked for 4 hours and your wage was 10, you'd make
$40.
$40. What math did you just do?
10 times 4.
We just multiply. So we're doing 4 hours, but we don't know what we make.
So 10 times X.
There is no 10. 10 was a made up for 1 second number that I had.
4x.
4x is correct. So the equation, we'd go 4x for the hourly part of the pay, plus the 6 for the tip, equals the 34, and then we'll go and solve that up. So opposites first, subtract 6, 34 turns into
28.
28, then you
Divide 4.
and get
7.
$7 an hour. Does that seem like a kid kind of job? Yeah. Front side, anything? To the back, pick a variable, I'd say not possible. So like word equation, nah. Variable, nah. Just write the equation using the code words. Start with 4, then
5x.
more than first,
4 plus 5.
plus 5x
Equals 39.
equals 39. Then do opposites.
Subtract 4.
Subtract 4 gets us
35.
35, then
Divide 5.
divide 5, get 7. Check, not possible. Like, there was no story to this. So is 7 a reasonable amount of things? I don't know, maybe, but maybe not. There's no way to know. There's no context to that story. Cookies, we could judge cookies, you know. So 5 we'll be able to take to the finish line. Bell's going to cut us off maybe. If it does, just stick around for a sec. Let us finish it. What's the X on number 5?
How many cookies?
For
Person?
each person. X equals cookies for each person. So if we get 1,000, that would be good or dumb? Dumb. You're not eating 1,000 cookies. So when we go to do the equation, where's the 45 slot?
45 in the beginning.
Is that the eaten cookies, the leftover cookies, or the total cookies?
Eaten.
Total.
That's the total cookies.
X.
The 5? It's the leftovers. The what each person ate has to have something to do with 10 and something to do with the X.
It'd be like 10x plus
Yep.
5 equals 45.
That's where we're going. 10x plus 5 equals 45 is a winning equation. Quick some opposites. First you'd
Subtract 5.
subtract 5, 45 down to
40.
40, then
Divide 10.
divide 10, get 4. You know, you're at a party, people eat 4 cookies apiece.
Yeah.
You probably have one greedy friend who goes far
Yeah.
beyond the 4, but that's like a normal, polite amount of cookies maybe to eat at a party where there's 10 people and there's 45 cookies. It'd be, 4. Again, homework, we're working 111, there's a 1 to 6, and then they start renumbering a new little section after 6, there's a number 2. So we're 1, 2, 3, 4, 5, 6, and then 2. On the ones that you can do it, do all this stuff. Do the word equation, do the x equals, do the whole bit.